Welcome to the deep dive. Today, we're taking a plunge into a topic that I know keeps a lot of us in DevOps and cloud engineering focused, securing your GitOps pipeline. Specifically, we're tackling a really high-stakes common security challenge using some pretty powerful tools.
Yeah, it's definitely one of those critical areas.
You know the scenario, right? An engineer, maybe accidentally, commits a Terraform module that deploys an S3 bucket with public access. We've all heard the horror stories, or maybe even had that near miss that just, made your heart race.
Oh yeah, millions lost, data exposed, trust completely shattered. It's definitely not just a theoretical risk.
Exactly. So our mission today is to really dig into how we prevent that nightmare scenario from ever seeing the light of day.
Good plan.
So let's frame this up like a critical question, maybe something you'd get hit with in a senior DevOps interview, right? How do you prevent public S3 bucket deployments in GitOps pipelines, particularly using tools like Conftest and Argo CD?
Okay, yeah, that's a solid interview question. It really gets to the core of secure infrastructure as code. So the quick answer, the one you want ready for that interview, it's basically this. You prevent public S3 buckets in GitOps by integrating Conftest policy validation directly into Argo CD's sync workflow.
Okay.
This creates what we call fail-fast security gates. It ensures that any non-compliant infrastructure, like a public bucket, it just can't read to production, period.
Fail fast security gaze. I like that. That sounds exactly like what we need. But okay, let's unpack that. How does Conftest actually do this heavy lifting? What's really going on under the hood?
Right, so Contest is essentially our policy engine. It uses Open Policy Agent, OPA, and its language, Rego. Think of Rego as a very precise, machine-readable rulebook for your infrastructure.
Okay, a rule book.
Yeah, and Contest takes this rulebook and applies it to analyze your Terraform plans, your configurations.
Yeah.
It's not just doing a simple text search, it actually understands the structure of your IAC.
Ah, so it's smarter than just grep.
Exactly, way smarter. This lets it pinpoint specific dangerous configurations. For example, if your Terraform tries to set an X3 buckets ACL, the access control list, to public read, Conftest flags it instantly.
Got it.
And crucially, it also checks for the absence of vital security settings, like is the OS3 bucket public access block resource missing? That block is absolutely essential.
Basically essential.
So Contest catches that too. It's all about proactive prevention, stopping the problem before it even starts, not cleaning up afterwards.
Okay, so Contest is clearly powerful on its own, but we're talking GitOps, and that usually means Argo CD in many shops. How does Argo CD, our GitOps delivery tool, actually enforce these rules? What's the secret sauce for making that integration work smoothly?
That integration with Argo CD, that's really what makes this whole thing click in a GitOps flow. It turns Contest from just a static analysis tool into a dynamic enforcement point. Argo CD uses either its config management plugins or resource hooks. There are a couple of ways to wire it up.
Okay, plugins or hooks.
Right. And the key is that this validation process runs before any Terraform apply actually happens. Your Terraform code gets rendered into a plan, first basically a preview of what would be deployed.
The preview, yeah.
Then Contest runs its Rego policies against that plan. And here's the fail-fast part again. If Contest spots any security violations in that plan,
A whole thing stops.
the entire Argo CD sync operation just fails, stops dead. It halts the deployment completely, preventing anything non-compliant from ever touching your production environment.
Yeah.
It effectively shifts security way left, turns your GitOps pipeline itself into a mandatory security checkpoint.
That's powerful.
And, this isn't just a single layer either. We can actually build a really robust security posture by putting these checks at multiple points. You could have pre-commit Git hooks, right? Catching stuff even before it hits the main repo.
Even earlier, yeah.
Then you have the Argo CD sync policies, which are kind of your main line of defense for infrastructure deployments. And while it's maybe a bit beyond this specific deep dive, you could even add runtime admission controllers, like for Kubernetes, as another layer.
So multiple layers of defense.
Exactly. This multi-layered approach means risky configurations get caught at different stages, hopefully long before they can actually impact production. And this thinking extends to continuous compliance too. Even if something drifts after deployment, maybe someone makes a manual change they shouldn't.
Which happens.
It happens. Those same Contest policies can be adapted to audit your live infrastructure and even trigger automated fixes. The ultimate goal here is a security-first GitOps approach. drastically cutting down the risk of those really costly data exposures.
Okay, this sounds incredibly beneficial, really game-changing. But for us, the developers, the engineers actually implementing and maintaining these systems, why Comtest specifically? Why not just whip up a simpler custom bash script or something? What are the real-world trade-offs involved here?
That's a totally fair question, and one you have to ask when choosing tools. The reason you'd go for Comtest over, say, custom bash scripts really boils down to structure and maintainability. Comtest gives you a proper, structured, policy-as-code approach. Your security rules, they become code, version-controlled, testable, maintainable code, just like your app code or your infra code.
Right, treating policy as code.
Exactly. Bash scripts might seem quick for a really simple one-off check, but they get messy fast. They become unwieldy, almost impossible to test reliably, and super prone to subtle bugs when you're dealing with complex logic or lots of rules.
Yeah, I can see that happening easily.
And when we talk about Rego, a PA's language, it's just leagues ahead of simple text matching. Rego isn't just looking for the string public read. It actually understands the complex relationships between different Terraform resources.
Ah, the context matters.
Hugely, it can spot those implicit security problems that might span across multiple resource definitions, stuff that simple text matching would completely miss.
Okay, that makes sense. But what about the downsides, the trade-offs?
Right, trade-offs.
Yeah.
Look, there is an upfront investment, no question. You need to factor in time for policy maintenance. And yeah, there's definitely a learning curve for OPA Rego. It's powerful, but it's a different way of thinking about policy.
A new language to learn, basically.
Pretty much. But, and this is the key point, these costs, they're minor. Honestly, almost negligible when you weigh them against the potential fallout from a catastrophic security incident.
Like a massive S3 bucket leak.
Exactly. The overhead of implementing Conftest and
Yeah.
maintaining policies, it's absolutely dwarfed by the financial penalties, the hit to your reputation, the loss of customer trust that just one public S3 bucket incident can cause. It's an investment that pays for itself many, many times over, often the first time it catches something serious.
Okay, that puts the cost into perspective. Now, for those of us who really like a clear analogy to help things stick, how can we simplify this whole concept even more? Give us that Feynman-style breakdown.
Absolutely. Let's try this. Think of Conftest and Argo CD working together like a super smart, incredibly diligent security guard stationed at a busy construction site. This guard's job is to check every single building blueprint before any construction crew starts working.
Okay, blueprints and a guard. I'm with you.
So in this picture, your Terraform modules, those are the building blueprints. They spell out exactly how you're going to build your cloud infrastructure, your storage buildings, which are like your S3 buckets.
Got it. Terraform blueprints.
The Conftest policies, that's the guard's comprehensive security rulebook. Big, detailed book. And that rulebook has strict rules like no storage building can have unlocked doors facing the public street.
Meaning no public S3 buckets.
Precisely. No public S3 buckets. Now, Argo CD, that's your construction foreman. This foreman automatically gets every new or changed blueprint from the central plan office, your Git repo.
Okay.
And crucially, the foreman hands every single blueprint to the security guard for review before anyone breaks ground. If that blueprint violates any rule in the security rulebook,
Construction stops.
construction stops immediately. Red flag. Stop work order. The real power of the GitOps workflow here is that every single change, no matter how tiny, goes through this exact same security checkpoint.
Consistency.
Total consistency. It ensures that nobody, not even by accident, can sneak a dangerous blueprint past the guard. So your infrastructure stays secure because this guard, which is really Comftest and Argo CD working together, never sleeps, never gets distracted, never takes a coffee break.
Uh-huh. Wish I had guards like that.
Right. And it always enforces the exact same rules every single time. It's security and consistency baked right into the process. Security by design.
That construction site analogy really works. It makes it very clear. The guard who never takes coffee breaks. But implementing this in the real world, well, it isn't always quite as smooth as a nice analogy. For our listeners thinking about actually rolling this out, what are some of the key architectural things they really need to think about?
Yeah, moving from analogy to reality always brings up considerations. Several key architectural points really need careful thought for a successful implementation. First up is policy scope. You definitely want resource-specific rules for things like S3, IAM, security groups. Makes
Not
sense,
specific,
right?
right?
The common trap here is making policies too broad. If they're too generic, you can end up blocking legitimate configurations, which just causes friction and frustrates developers.
Okay. Avoid overly broad rules. What else?
Next, think about the integration point within Argo CD. We mentioned plugins and hooks earlier. While pre-sync hooks can work, using an Argo CD config management plugin is often, well, arguably superior.
Why that?
It generally gives you better error reporting if something fails during validation, and potentially more robust rollback capabilities if the sync goes sideways after validation but before completion. Just a bit cleaner, usually.
Good tip. Plug in over hooks, generally.
Then there's policy storage. This is a big one. It's really vital to have a centralized policy repository, ideally versioned, like with Git tags or releases. This ensures all your environments are using the same rulebook.
Consistency again.
Exactly. The gotcha here is needing a coordinated rollout plan for policy updates across all your clusters. You don't want some environments running old, possibly insecure rules, while others have the latest fixes.
Right. Keeping everyone in sync.
And finally, don't forget performance impact. Conftest validation happens during the Argo CD sync. If you have massive Terraform plans, hundreds of resources, that validation step can significantly slow down your sync times.
Ah, so it adds overhead.
It does add a bit of overhead. It's usually negligible for smaller plans, but for huge ones, it's a trade-off. You need to be aware of that balance between security rigor and sync speed. You might need to monitor and optimize.
Okay, scope, integration point, storage, performance. Got it. So we've talked a lot about the why and the how conceptually. For someone who's maybe never actually done this before, can you walk us through a conceptual implementation? No need to read code, but what are the actual steps conceptually to bring this to life?
Sure, let's trace the conceptual path. First step, you'd need to install Conftest itself. It needs to be available where Argo CD runs its logic, which is usually the repo server container.
Okay, get the binary in there.
Right. A common and pretty robust way to do this is using an init container in your Argo CD deployment. This little container runs first, copies the Conftest binary into a shared volume, and then the main repo server container starts up and can access it.
Neat trick with the init container.
Yeah, keeps the main container image cleaner. Next, you define your actual S3 security policy in Rego. Conceptually, this policy needs the logic to say deny if it sees an S3 bucket with a public read or public read-write ACL.
The forbidden stuff.
Exactly. And, equally important, it needs to enforce that all S3 buckets must include that auth3 bucket public access block configuration. If that block is missing, it's also a deny.
So deny bad things, require good things.
That's the core logic. It's declarative. If this bad pattern exists, or if this required good pattern doesn't exist, then fail. Finally, you configure your specific Argo CD application to actually use this Conftest validation.
Tell Argo to use the policy.
Precisely. In your Argo CD application manifest, you'd specify that it should use a custom plugin. Maybe you name it Conftest Terraform. Within that plugin's configuration, you point Argo CD to where your Conftest policies live, maybe a policies directory in your Git repo.
Put it to the rulebook.
Exactly. This setup ensures that every single time Argo CD tries to sync that application's Terraform, it first calls out the Conftest to validate the generated plan against those rules you wrote. If any rule gets violated, sync fails. No insecure deployment. It's like building that conceptual no-go button right into your pipeline.
That's a really clear conceptual flow. Install Conftest, write the Rego policy, configure Argo to use it. Makes sense. But as we all know too well, things don't always go perfectly smoothly in the real world, do they?
Rarely.
So when you're actually implementing this or troubleshooting later, what are some common scenarios or problems we might run into? And more importantly, how do we fix them?
Oh yeah, you'll definitely hit some bumps. Knowing the common ones saves a lot of headache.
Oh.
Okay, one common observation. Conftest validation passes, everything looks green in Argo, but somehow a public S3 bucket still gets deployed.
Wait, how does that happen?
Well, the why is often that the policy only checks the Terraform plan. It doesn't watch the actual AWS API calls during the Terraform apply. Maybe something else outside of that specific Terraform run modified the bucket, or the plan didn't fully capture the end state for some reason.
Ah, the gap between plan and reality.
Exactly. The fix here is usually to add runtime validation. Think AWS config rules continuously checking deployed resources, or maybe OPA gatekeeper if you're in Kubernetes and want to check things interacting with S3 at the K8's API level. Layering defenses.
Okay, runtime checks for post-deployment drift. Good one. What else?
Another frequent one you might see, Argo CD sync fails with the Conftest command not found error. Straightforward, usually.
Sounds like it just can't find the tool.
Yep. Usually means the Conftest binary isn't properly installed in that repo server container, or maybe it's installed but not in the system's path. The fix is what we discussed. Use that init container reliably, or build a custom repo server image with Conftest baked in.
Makes sense. Check the installation.
Then you might run into policies triggering false positives, flagging legitimate internal-only buckets as violations.
Annoying for developers?
Very annoying. This usually happens when your policy is too simple and doesn't distinguish between different contexts. The fix is to refine your policy. Maybe add exceptions for specific internal naming patterns, or even better, require explicit security annotations or tags on resources that are intentionally internal, giving your policy more context to work with.
Make the policy smarter.
Right. Another one, performance-related. Large Terraform plans causing Argo CD sync timeouts during the policy validation step.
We touched on that, the overhead.
Exactly. The why is simply that Conftest evaluation takes time, and it scales with the size of the plan and the complexity of your policies. For fixes, you'd look at optimizing your Rego policies. Sometimes there are more efficient ways to write the logic, or breaking up those huge Terraform monoliths into smaller, more manageable modules that get validated independently.
Optimize policies or split the plans.
Okay, and one last common scenario. The security team updates the central policies, but you notice some clusters are clearly still using the old rules.
The consistency problem again.
Yep. This points directly to decentralized policy storage, or just no reliable sync mechanism. The solution is that centralized policy distribution system we talked about. Maybe use an OCI registry for policies, like you do for container images, or set up a dedicated policy server that all your Argo CD instances pull from. Ensures everyone gets the updates.
Centralize and distribute policies properly.
Got it. That's a great list of common issues and fixes.
Hope it helps. So, just to kind of wrap up the critical points for you, the listener, thinking about this maybe for an interview or for your own systems. 1. GitOps security is fundamentally about shifting left, catching issues early, proactively, in the pipeline, not after deployment.
Shift left. Key concept.
2. Conftest and Argo CD together give you a really powerful automated policy as code solution for your infrastructure. Security rules become living code.
Policies as code.
Right. 3. OPA Rego lets you do sophisticated, context-aware policy enforcement, much smarter than just text searching. It understands infrastructure relationships.
Context matters. 4. Implementing this well means thinking about architecture, things like policy scope, where you integrate it, policy storage, and performance impact. Don't just throw it in.
Plan the implementation.
And 5. Ultimately, this whole approach transforms GitOps from just a deployment tool into a robust security enforcement point. It helps make your infrastructure code secure by default and seriously reduces the risk of those big, costly mistakes.
That was truly a deep dive. Fantastic stuff. We covered not just the tools, contests, and Argo CD, but really the deeper architectural thinking, the operational side, the troubleshooting, all crucial for actually securing a GitOps pipeline effectively. It's clear this integration provides really valuable, actionable knowledge for anyone in DevOps or cloud engineering. It feels like it really changes the game for preventing those critical misconfigurations. I really hope this gets all of you listening thinking about how you might apply these principles, these patterns, to really fortify your own GitOps workflows.
That's all for this topic. Stay tuned for the next DevOps Cloud interview question.